Welcome to the next video in the Captain Graham series for charting for the U.S. Coast Guard class. So we're now going to do a problem that called Find the Course to Steer. And they use the word course. They don't say the word compass course. They just say course. Or they might say course made good. They might say true course. But unless they say compass, they're always talking about true course on the chart. So find the course to steer when you have a current pushing you. So let's read the question. Question is, you're at location A and you want to go to location C. You have not left yet. You're thinking about this trip and you're planning your trip. You're going to travel at 12 miles an hour. They tell you that there is a current with a set of 180 degrees. So there is a current going 180 degrees down this body of water. So if you aim straight at C, you're going to end up below it somewhere. It's going to push you down. Okay? So what formula do we use to find this? We have things like miles per hour. So immediately that would mean that we need to start thinking about using our 60D street. Nowhere in here in the question does use the word compass. Nowhere in there is compass, so we don't use the compass correction formula, which takes true chart, and converts it down to compass, or takes the compass and converts it up to true. We don't have to do that. Okay? So we think that we might be using 60D street, so we put 60D street on our paper, on our worksheet, and we now look at the problem. So the first thing is, it says that we are on a course. We want to go from A to C. So we draw a course line from A to C. That's the course that we are on. We haven't actually gotten there yet. We haven't actually left yet. So where should we be on that course after a certain period of time? Well, there's no time in this. We haven't left yet. So we're going to assume $60 minutes. Because if we do this, I'm just going to give you a quick explanation. We say that 60 minutes we would be right here. And we did the 60D street to find distance, so it'd be 60D street. We would assume 60 minutes. Our speed is 12, so our distance is 12 times 60 divided by 60, which is distance is equal to 12 miles. Makes sense. If we pick 1 hour, it's 60 minutes, how far are we going? How far do we travel if we're going 12 miles an hour? It'd be 12 miles. Right? And then we would look at the current and say, oh, the current is pushing us down in that direction. The current. Because it says 180 degrees. And we would take 180 and we'd move it over with our tool. Then how far have we moved in 1 hour? How far would the current push us? Well, it would push us about 5. And I'll just pick right here, 5 miles. So in order to compensate for that 5 miles, and we would do 60D street to come up with the 5 miles, but you kind of know that if you're going 5 miles an hour, in 1 hour you've traveled 5 miles. So we would flip this and say, okay, 5 miles, we would have to lean into the current. We'd have to head upstream 5 miles. So we said that we were going to assume a time of 1 hour because it makes the math easier. What if instead we assumed that the time was 2 hours? Would we end up with the same number? So time is equal to 120 minutes, which is 2 hours. So instead of being 12 miles, so we travel 12 miles an hour, 2 hours, that would give us 24 miles. So we'd be right there. The current would push us not 5 miles, but 10 miles. So if we did that, didn't do a really good job of this drawing, the course angle is the same. It doesn't matter what number we use for our time. So let's pick an easy one. Let's always pick time is equal to 60 minutes. Okay, so now let's do the problem in detail. Oops, erase all this stuff. So this is, we have not left yet, and we want to know our course to steer. So we know that we're going from A to C. So let's do that again. You need to do it more accurate than this tool will allow me to do. Come on, I used to be able to get it much better. Okay. So do a much better drawing of that. You then take 1 hour at 12 miles an hour. So we would be 12 miles along that path. And we should be just about here. And that's where we would go. That's where we would head if there was no current to our estimated position. Now we know we have a current going 180 degrees at 5 miles an hour. So we take our trusty little ruler tool and we draw we get 180 degrees, which is straight north and south. Come on. That's close enough. And we draw from there down. That's the current pushing us. How far down does it push us? Well, we're going at 5 miles an hour. So in 1 hour, how far do we travel going 5 miles an hour? 5 miles. So we take our tool, do 5, put it up against here, and we got 5 miles. Now, if we aimed for this location, well, the current would push it would push us another 5 miles down. We don't go with the current. We aim upstream of the current. So we take our current directions, extend it up, and we mark the same 5 miles. Now we have a direction that we aim in. I'm going to do it in red. So now if we aim in that direction, if that's the course that we're going to steer, we will actually go to C, because every time we start aiming, we aim high, and the current will push us down to our course line. So if we measure that, and I've measured it, I've done this on paper, just like you're going to do it on paper, should be about 88 degrees. But there's one more thing that it says in the question, and that is you also have a northerly wind pushing you 2 degrees. Now remember, winds, if you think of wind, always think of which way is westerly. What's a westerly wind? Westerly wind is coming from the west going to the east. So a northerly wind is coming from the north. Oops. So the wind is coming from the north, pushing us south. And we don't have to know the wind strength and all that, because they tell us that it's going to push us 2 degrees off course. Which way is it going to push us 2 degrees? It's going to push us this way, 2 degrees. So what do? I lean into the wind. So I lean into the wind 2 degrees. Now, do I add 2 degrees or subtract 2 degrees? Well, here is my 88, roughly. So if I go this way, are the numbers getting smaller or bigger? Well, the numbers are getting smaller. So I subtract 2 degrees. And I should come out with about 86 degrees. Okay? Thank you for listening.